Okay, types of radiation. The types of radiation that we are talking about are ionizing radiation, but very specifically, ionizing radiation that can be produced by a radioactive nucleus. Okay, so for example, ultraviolet rays, they are ionizing, but they're not what we're talking about. X-rays as well, we're not really going to consider those because they're not produced in the nucleus. So unstable nuclei will produce ionizing radiation. Okay? If they're unstable, the nucleus, something changes. Okay? We're going to look at what the changes could be, or it literally just breaks off a piece of itself and emits it as ionizing radiation. That radiation then goes on and it can cause ionization in cells inside the body, for example, and different things. Okay, that's dangerous, we know, because if our cells become ionized, chemical reactions can take place, mutations can occur, and eventually that can lead to cancer. So, the three types of radiation that we're going to look at now are alpha, beta, I'm going to put beta minus, and beta positive, and gamma. Okay? The symbols that you may see are alpha, beta minus, beta plus, and gamma. Okay? Alpha radiation is specifically a particle made of 4 subatomic particles, 2 protons, 2 neutrons, and it has a charge of +2. It has a mass +4. Okay? We also need to discuss how ionizing is it, just how dangerous is it. So ionization potential, and finally, how far can it travel before it's stopped, so penetration depth. Okay? Alpha is the highest and most ionizing. Okay? It has a very short penetration depth. Because it is so ionizing, it won't travel far before it ionizes something. Okay? Meaning that its penetration depth is actually very short. It's a few centimeters in air. And if we're thinking about what materials could stop it, paper will stop alpha. Okay? So it can be stopped by, or literally will travel maybe that far in the air before it ionizes and then becomes neutralized, or if you just put paper there, it will stop it. Beta minus is an electron. So an electron is produced in the nucleus of the atom. It's not one of the electrons from the outside orbiting shells. It is just produced in the nucleus because of the instability. It's emitted, it's dangerous. Okay? It's fast moving. The charge of the electron is -1. The mass is negligible. Ionization potential, we'll call it moderate. It's quite high, it's not that low, but it's not as high as the alpha, so it's moderate, and it can be stopped by aluminium. Okay? So beta minus can be stopped by aluminium. Beta plus is a positron. This is the particle that is created inside the nucleus. The positron has a charge of +1. It also has a negligible mass. The positron is essentially exactly the same as the electron, except it's its mirror image. It's the antimatter particle of the electron. It has the same mass, it just has opposite charge. Okay? Ionization potential, it's also moderate. It's the same thing basically as an electron, except for the penetration depth of a positron is slightly different. We say that it annihilates as soon as it comes into contact with an electron. Okay? Essentially, antimatter and matter. If you have the two particles, the mirror image, electron, positron, they come together, they will destroy one another and then produce gamma rays. Okay? But in terms of its penetration, it's very likely that it will meet an electron quite quickly, so it is destroyed quite quickly as well. Okay? Gamma is just EM radiation. It has 0 charge, it has 0 mass. Its ionization potential is lowest compared to all the others. It is still very dangerous, and it still is very ionizing to humans, but it's the lowest of all of them. And in terms of penetration depth, it has the longest penetration depth. It will travel the furthest before it ionizes anything. So we stop gamma with lead. Okay? But lead can therefore stop all of them. Don't just think, okay, only paper stops alpha. No, if paper stops alpha, pretty much anything can stop alpha. Alright? Even literally that much air will stop alpha. Lead, if it stops gamma, then it must stop all of them as well. Okay? Stop by all of them. Now what you need to know is, right, if these are the types of radiation that could be produced in a nucleus, why and how are they produced? Alright? So for the alpha, if we start with uranium-238-96, they may not be the right units, numbers, but it doesn't matter. If uranium decays because it's unstable and it emits an alpha particle, a helium nucleus, then the new element, call it X because we don't know what it's going to be, plus a helium nucleus which is 4,2. Then the mass number drops by 4, becomes 234, and the atomic number drops by 2, becomes 94. Okay? It literally just breaks away 4 of its particles in its nucleus and emits the alpha on its own. These are the decay equations. All you need to do is say whatever I start with here at the top, I have to finish with on the other side. So if I start with 238, these two things on the top must add to make 238. So if a helium nucleus or an alpha particle, which I know has a mass of 4, the missing mass on this new element must be 234 to balance the 238. If it started with 96 protons, and the helium nucleus of the alpha has 2 protons, which I know it does, then the missing proton number on the X must also be 94, because 94 plus 2 give me back my 96. Okay? Beta minus, that's alpha. Beta minus decay. Start again, it may not undergo beta, but let's just say it does. Uranium-238, 96, okay? If a new element X is created, plus an electron, which is 0 mass minus 1 charge, okay? The new element formed must also have 238 to balance the left-hand side. 238 plus 0 is still 238. And something minus 1 makes 96, so that must be 97. Yeah? To do these decay equations, all you need to do is match the numbers. There's no understanding of what is going on, just match the numbers. But if you have a look, the mass number has not changed, but the proton number has. The only way that is possible is if a neutron turns into a proton and it creates an electron. So in beta minus, neutron turns into proton plus an electron, and the electron is the ionizing radiation that is emitted from the nucleus and can go on to cause ionization as well. Okay? Beta positive, very similar. Start with the uranium-238, 96. New element is formed. Add on the positron, which has 0 mass plus 1 charge. Again, there's no mass here, so that means that the mass of the new element has to be the same as before, 238. Something add 1 gives me 96, that must be 95. What has changed? The new element has the same mass number, but it has dropped a proton. The only way that can happen is if a proton turns into a neutron, and as a result creates a positron. Okay? Charges have to balance. I start with 0 charge, I finish with an overall 0. Plus 1, minus 1, 0. I start here with plus 1, and I go to 0. The positron has plus 1, my charge is balanced. And you can see that in the decay equation just by matching the numbers. The last one is quite easy, which is gamma, I'll put it here. Uranium-238, 96. Something plus gamma. Well, I know that gamma has 0 mass and 0 charge, so the numbers of the new element have to be exactly the same, 238 and 96. So the element hasn't changed. What has happened is the nucleons inside the nucleus have just moved, rearranged into a more stable energy state. Okay? It's a little bit like an electron in a shell dropping, emitting energy, becoming more stable. The nucleons in this element have basically dropped to stay, emitted energy, become more stable, but it didn't change. Okay? So that is types of radiation, all the different things you need to know, decay equations, what is going on inside the nucleus. Alpha is easy, it just throws out 2 protons, 2 neutrons, balance the numbers. Gamma is easy, it just emits ionizing EM radiation, nothing changes on the mass or the atomic number. It's the beta minus and the beta plus that you have to be careful with, but just match the numbers up. Neutron turns to proton, creates an electron for beta minus. Beta minus because the electron is negative, that's created. Proton turns to neutron, plus a positron is beta positive, because the ionizing radiation created is positive. Okay? And that's types of radiation and radioactive decay. Mohammed?